Now that we've had a look at simple areas on the Cartesian plane, we're going to have a look at feasible regions. Now, feasible regions talk about every single point on our graph that is allowed by the different constraints or the different equations we have. So let's imagine we have a few equations here. Let's imagine one of them says that x is greater than or equal to 0. A second one says that y is greater than or equal to 0. That's going to put us in this part of the Cartesian plane. Then we might have a few other constraints. Let's say y is less than 50, and we might have a fourth one, x plus y is less than 75 for argument's sake. We might even do another constraint where x plus y is greater than 10. So now I've got a whole lot of different constraints. And what we're going to do is we're going to sketch all of these constraints on our Cartesian plane to find the area that actually fits all of these. So there may be a space where certain points fulfill all 5 of these criteria. So let's have a go really quickly. For x to be greater than 0, that means we must be to the right-hand side of this orange line, the right-hand side of the y-axis. And because it has an equals there, we know it's going to include the y-axis as well. So we could say that that's this part of the graph. For y to be greater than 0, then it's the same, although with the x-axis. So we have a solid line because it has an equals to as well. And we're looking at this area now. The next one, for y to be less than 50, that means I'm going to draw a line at the point of 50 on the y-axis. So let's make a point here. But you'll notice this one is less than, it doesn't equal. So that means it's the area under here. Now you can see things are going to start getting complex because I'm going to have 3 or 4 or 5 areas of shading. So what I might do, just for the part above my region, this is no longer viable up here. So I'm going to delete that and make it black again. So I know that the area that I'm looking at is just the area that I've highlighted. That would also mean now getting rid of this space. So I know so far the area that fulfills all 3 of these criteria is this area in here. The next criteria is that x plus y is less than 75. Now that line is going to look like a diagonal line starting at the point at 0.75 on the y-axis and finishing at the point at 75 and 0 on the x-axis. So it's going to be a broken line that looks like that. So let's draw that in as a broken line. And this less than area, that's actually going to be this area here. And we can now see we have more spaces that are not allowed. This space up here is still not allowed. But also, all this space to the right-hand side of that dotted line is not allowed. So all of this area here is now no longer in our feasible region. So we're going to get rid of that. Or what I'll do is I'll just colour around it in black so we know that that's not feasible. And our final feasible region is, or our final equation is x plus y is greater than 10. That's going to look something like this from 10 to 10. Notice the dotted lines are not included. So the only space that has every one of these equations fulfilled is this bit that I'm colouring in green. Now you might notice a couple of difficulties with doing it this way. One of them is that we end up with a whole lot of space where we've got colours and colours and colours, but not all 5 of them, and therefore those areas shouldn't be included. So I'm just trying to tidy that up a little bit now. Secondly, we need to find our corner points as well. So right now we know that we've got a corner point here somewhere, but we don't know what it is. We do know, though, it's at the intersection between y is 50, which is the dotted blue line, would be at y equals 50, and the purple line, x plus y equals 75. Now you'll notice I've used equal signs, even although we have inequalities over on the left-hand side. That's just to help us find the point of intersection. And on our calculator, we can find out that this point of intersection will be at 25 and 50 by using simultaneous equations. So now we know that. Every other point is clear. And what it means is now we can look at this region and clearly show our feasible region. So this region now in white is our feasible region. You'll notice there are dotted lines when my inequalities don't have an equal sign. And there are solid lines on the boundary where my inequalities do. I've also labelled all of the corner points, which is really important. So we need to make sure we do that as well. Now, because of this messy thing when you do it by hand, of course, we can use the calculator, and the calculator has a function that's really useful for doing this. So let me set this up in the calculator and show you how to make it so that the region that covers all 5 of these inequalities is very easy to see on the calculator. Now this is the Casio ClassPad, and I'll show you a couple of little functions that are going to help you here. First of all, the calculator is normally set up with all y's down here. But we've got x's, we've got greater than or equal to, we've got less than, we've got all sorts of stuff. And you can find all those inequalities in this drop-down menu where the arrow is pointing down. So my first one is x is greater than or equal to. So I'll look down my options and get to x is greater than or equal to, and I'll click that, and then for my first inequality, I'll write 0. And you can see that writes my inequality exactly the way I want it. The second one is y greater than or equal to 0. So now for the second one, I find the y function, and then I put that in the same way. The third one is y is less than 50. So I'll drop down and I see the y is less than, and I click that, and I'm going to write 50. Now for the next two, it becomes a little bit more complex. I actually have to write these in terms of y. So what I'm going to do is I'm going to go to the main menu command, and I'm going to write this equation in. X plus y is less than 75. So I'll look in the maths commands until I find the less than 75. And then I'm going to solve this for y, which will give me the equation in the form of y is greater than or less than or something. So I hit OK, and you can see it tells me y is greater than negative x plus 75. This is what I'm going to put into my graphing part of the calculator. So I'll go to my menu, and I'll put graph and table, and the fourth one, remember, it's going to be y is less than negative x plus 75. I might even copy that to make it easy. So in graphing, I need y is less than. You can see I already have that. So then I can paste my negative x plus 75. My fifth one, x plus y, is greater than 10. Again, I can jump back to the main menu and write x plus y is greater than 10. So remember, it's in my keyboard, Maths 3, greater than 10. And then I'll solve this one as well for y, and it'll tell me that y is greater than negative x plus 10. I have to remember the greater than, but I can copy the rest of it and then go into the graphing area. And remember here I need y is greater than, which is here. And then I paste my negative x plus 10. And these are my 5 regions that I've written in my question. Now you'll notice, much the same as when we did it manually and shaded in the area we wanted, that when I get the calculator to do this, I get a whole lot of areas all over the top of each other. And this can become really confusing. So what I can do is go to my setting, which is this little wheel here. I can click on it and go to graph format. And rather than the union on the inequality plot, I'm going to select intersection and then hit set. And what happens is the graph will only shade in the area that is fulfilled by all of the criteria here. So now I have my graph. You can see I have my dotted lines for my equations that have greater than or less than. And I have solid lines for the ones that have the equals to in it. Finally, if I want to find my points of intersection, for example here, I can hold my hand over there and I can see that it's approximately 25 and 50. That'll give me a really good guide. Another way I can do it is to go to GSolve and intersection. And what'll happen is the calculator will ask me which lines I want by flashing a line. Here I have this red line. Do I want the red one? No. So I'm going to move the cursor to the next line and the next line and the next line until it gives me the line that I want. Here's the black line flashing. No, I don't want that. I want this one. You can see this one's flashing now. So I'll press enter. And then it will give me a second option. Now you can see this line's flashing and I'll also hit enter. And now it tells me the point of intersection of those two lines. So that's how we can create feasible regions, both manually and using our calculator. Remember that with Further Maths, you'll always have the chance to use your calculator, so it's a really good skill to have to be able to do that and to make sure the area that you find is clear and easy to read and sketch. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.